Good morning, 8th grade. Today we'll talk a bit about conversion between units, and then we'll introduce map scales. Then we'll start using your textbooks, because you might be wondering, when do we start using the textbooks? Well, this is the chance. After today, we'll be using the textbooks, I promise. So, in order for us to start to even look at map scales, one important thing that you need to remind yourself of is conversion between units. So converting, especially length units, because this is going to be a very important idea in map scales and proportions. So if you want to go from kilometers to meters, simply multiply by 1,000. If you want to go from meters to centimeters, multiply by 100. And if you want to go from centimeters to millimeters, that's not very common, but you just multiply by 10. If you need to do the opposite of those things, the opposite is here shown in blue, you would just divide. If you want to go the other way around, you would just divide. For example, if I want to change 5 kilometers to centimeters, right, then what do I have to do? I want to go from kilometers to centimeters. So I'll multiply by 1,000, and then I'll multiply by 100. So that's 100,000. So my answer would just be 500,000 centimeters. Okay, what if I need to change 20 centimeters back to kilometers? What would that be? Let's go back and see. If I want to go from centimeters to kilometers, right? All I have to do is divide by 100 and then divide by 1,000. So I'll get this 20, I'll divide it by 100, I'll get my answer and divide my answer by 1,000. So it's as if I have divided the 20 by 100,000. By the way, in case you were wondering, I have the best handwriting in the school. So yeah. When I divide this, I'll get, let me see, 2 divided by 10,000, which is the same as 0.1232. Pause the video and try this one. Can you change 1,200 centimeters to meters? And can you change 30,000 meters to centimeters using the conversion chart? So try to see if you can do that, because this is going to be important when we start talking about map scales. Now I'm pretty sure that each of you guys has a phone or a Google device or something, and on that device you have Google Maps. A map has a scale. Maps have scales because you cannot fit the map of the entire world on something small. If you're using the actual distances, you cannot fit it on a small chart or a piece of paper or even a phone. You need a scale in order to be able to explain what that map is about. Just noting, every time that I'm doing a presentation and I show you something in red, that means I want you to write it down. So all of this is in red, so please write it down. It will also help if you write this down as well. I know it's not in red, but it's very useful. So you can also go ahead and write that conversion chart down. As always, you can just pause the video and write what you need to write, and then you can proceed. So a proper map has a scale. Proper map has a scale that shows the relationship between the distance on the map and the horizontal distance on the ground. Maps show us relationship between distance on the map and distance on the ground. So if you think about it critically, look at the words, a relationship, right, between a distance on the, I cannot draw straight lines, a distance on the ground, on the map, right, and another distance on the ground. So what we're doing is we are relating two numbers. And if you're relating two numbers, we use what you call a ratio, right? we're relating two numbers. Those two numbers are the distance on the map and the distance on the ground. And in order for us to do that, in order for us to relate or compare two numbers, we use what is called a ratio. A ratio can be written as a fraction, or it can be written as, as a ratio like that. So that's what a map scale is all about. Let me show you an example. This is an example of a map, right? This is a map of Kampala, Nakawa, and all of the surrounding villages and areas or towns. I want you to look at the bottom right corner, and every time you look at a map on your phone or your computer, look out for this thing. Okay? Look at the bottom right corner. Do you see that little thing, that one right there, and the 2 kilometers next to it? It may not be very clear, but this simply tells us that a distance of that size on the map represents 2 kilometers on the actual ground. So if I try to transfer this, distance, we try to transfer this distance. If I yes, that, come on, there we go. That distance, if I transfer it on the map, right? For example, I'm taking it to IHK International Hospital, Kampala. That's telling me that there is 2 kilometers between that and I don't know what's near it. But that's basically what it's saying, that the distance between, for example, these two roads, that's about 2 kilometers. So if you're wondering, oh, how long is it going to take me to get from Kirinya to Bukasa? Well, it looks like it's around 2 kilometers if I rotated this thing like that. It's around 2 kilometers, right? You see Kirinya to Bukasa, around 2 kilometers. So if I'm walking, that's going to take me about 5 minutes if I'm as fast as Mr. William or Miss Fiona. But if I'm too slow, like I don't know who, it will take me however long it takes me. But that's the idea, that distance on the map, that little distance on the map represents a bigger distance on the actual ground. And that's how we're able to read maps, and actually in the first place, that's how we're able to make maps, right? That's how we're able to make maps, by scaling them by using a scale. Okay, so moving on. When I zoom in, I want you guys to see this because you guys zoom in a lot. When you zoom in, the scale changes, right? The scale changes. I hope you can see down here that the scale has changed all the way down here. Instead of saying 2 kilometers, what it said before, it now says 1 kilometer. And why is it saying 1 kilometer? Well, that's because you have now zoomed in, right? You have now zoomed in. So now the distance between this distance represented by that blue thing that I'm swinging around, it represents 1 kilometer on the actual ground. I think it's pretty accurate because I have Palm Cafe here, and I'm going to try to look for something that is close to Palm Cafe. Let me see. Palm Cafe and IHK. Yeah, Palm Cafe and IHK. A bit more than 1 kilometer. But yeah, what this means is that a distance of this size on the map, if I go anywhere on the map and I have this size, then that's 1 actual kilometer on the real ground, right? That's 1 actual kilometer. The distance between these two blue dots, that's approximately 1 kilometer. So that's what map scales mean. Now, how can we work with map scales? Let's start with this example. The map has a scale of 2 centimeters to 5 kilometers. Okay, 2 centimeters to 5 kilometers. If two mountains are 7 centimeters apart on the map, how many kilometers apart are they? Right? How many miles? I don't like miles, so we don't have to do this part of the question because the standard unit is kilometers anyways. So let's start with this scale. 2 centimeters on the map is 5 kilometers on the actual ground. Now, every time you have a map scale, the map scale has to be in this form always, 1 to something else. 1 to something else, right? 1 to something else. So the very first thing you do if you have a mark scale that is not reduced is reduce it. But before we even reduce this one, if you look at the units, they're different. It has to be in the same units. This has to be centimeters, right? And this has to be also centimeters. So we're going to change 5 kilometers to centimeters. And reminding you, when I'm changing kilometers to centimeters, I multiply by 1,000, and then I multiply by 100. So that's multiplying by 100,000. I'm going to multiply 5 by 100,000. So I will have 2 centimeters to 500,000 centimeters. Now at this stage, I can divide by 2 so that I can reduce it. Divide by 2, so I have 1 centimeter represents 250,000 centimeters. I don't even have to write the centimeters because they are the same unit, so they cancel out. So this is my scale. 1 centimeter on the map represents 250,000 centimeters on the ground. That is the scale I'm working with. Okay. Again, cannot draw straight lines. Alright, so next part is trying to solve this question. 2 mountains are 7 centimeters apart. So if 1 centimeter on the map is 250,000 centimeters on the ground, then 7 centimeters on the map will simply be 7 times 250,000. So I'll multiply that on my calculator, and that's my answer in centimeters. Then I'll have to change it back to kilometers, which is something you guys can do very well. So I hope you're doing this exactly in your book. So when I multiply 7 by 250,000 on my calculator, I have 7 times 250,000, 1,750,000. And if I want to change that to, this answer is in centimeters. If I want to change that to kilometers, remember, what do I do? If I want to change it to kilometers from centimeters back to kilometers, I divide by 100, then I divide by 1,000. So I'm just going to divide by 100,000. I'm going to divide this answer by 100,000, and then it will be in kilometers. So I'll divide by 100,000, and my answer is 17.5 kilometers. Good job, people. Okay, last example. The distance between Wolverhampton and Stafford, these are places in China. No, not China. They are places in Kenya. No, not Kenya. We don't know. How far apart in centimeters will they be on a map whose scale is 1 to 50,000? Now I want to clarify again that every time you see a map scale and it's written in this form, the form that you see up here, those units are both centimeters, right? That's both centimeters. So they're telling us that 1 centimeter on the map is 50,000 centimeters on the actual ground. So if the distance between Wolverhampton and Stafford is 27 kilometers, how far apart are they on this map? Let's see. So this map says first thing we're going to change this down to centimeters. If I'm changing this to centimeters, I'll just multiply it by 100,000. So I have 2,700,000 centimeters. Now, 1 centimeter on the map represents 50,000 centimeters on the ground, right? How many centimeters on the map? This is what we want to know. How many centimeters on the map will represent 27, read that in once. 22,700,000 centimeters on the ground. That's what we want to know, right? How many of these centimeters? So if you think about it critically, if 1 centimeter is 50,000, and you're trying to figure out how many centimeters are in 2.7 million, right? All I have to do is divide the 2.7 by 50,000, and I will get the distance on the map. So I'm going to divide 2.7 by 50,000. So that gives me 54 centimeters. That's my answer of how many centimeters on the map they are. So when I look at this map, I know that this distance on the map is 54 centimeters. Okay, so that's it for today. If you have any questions, please let us know.